The normal curve. Now, it's a bell-shaped curve is how it looks. It's used quite a bit in statistics. It's under the assumption that most things follow the same kind of pattern. And so let's just draw a picture of a bell-shaped curve. It looks something like that. This is like a x-axis. In the middle we have a 0. And these numbers on this line are actually called z-scores. What it's saying is that most things in life are right about the same, think about the same thing, or are about the same thing. It's just an assumption. Now, there's a table that's associated with this, and it looks like this. This is from your book. It's actually page 772 and 773. It's called a normal curve, and it has a bunch of data values, or a bunch of values. These values are like areas. And if you look here, it's telling you that the shaded region is an area to the left. So this particular example that's in the book, that's what the table is saying, that this z value, that this represents the area to the left of the z value, and that's what these table values are. So where those come from, if you really want to know, they come from dividing these up into rectangles, smaller, rectangles. And when you do that, for every one of them, for the whole curve, the whole area is 1, because 100% of the curve is being drawn. And so these areas, once again, they do correspond to proportions and percents and whatever else. I mean, mainly it's proportions and percents. So the table value is area to the left of z. That's the most important thing. So we'll erase this. Well, let's just erase the whole thing. Okay, we will. So if I were to give you like an arbitrary z value, z squared, say right here, if I looked at the table value that represents that z squared, it's going to give me the area to the left of that. It's going to actually be really small. Now, I've been mentioning z-score. A z-score, what it is actually a way to convert data values to z-scores so we can use that table that I've mentioned, that table. And this formula will do that. This formula, it just says value minus mean divided by standard deviation. What this z-score actually is the number of standard deviations that the value is from the mean. That's what it really is. But we're just going to recognize that it converts data values to z-scores. So before we can actually use this, we got to learn how to use the table. So let's find some actual table values for certain z-scores. So this first example is z equals 2.45. So we have these are the negatives, and if I go to the next portion of the table, these are positive z-scores. So I'm looking for z equals 2.45. Now if you look up here, we have hundreds places, and if you look here, first off, that's the z. Down here is the ones in the tens place. So these digits are found on this side, and then the 5 is found up here. So it's actually over here. So these are like the hundreds place. That's terrible handwriting. But it's supposed to say hundreds. Ooh, look at that. So, once again, we're doing 2.45. So we come over here, 2.4, we find it here. And then the 5, which is in the hundreds place, we find it here. So what we want to do is to find where these, or this, and this converges. And where they converge is right there. So I'm going to erase that. I'm going to erase that. And you'll see that that table value is 0.9929. Catch that? So we went over there and we went down here. And they converged at 0.9929. So that is the table value. 0.9929. Some people may not be able to read that in that color. 0.9929. Now this other table value, or z-score, is negative 0.08. So let's go there. Negative 0.08. These are positives. Negative 0.08. So we're in the negatives. I better write that over here so we can use it as a reference. So negative 0.0, we got to look at, find these first and then find that. Negative 0.0 is there. And then we're looking for the 8 on top, which is here. I'm having issues with this table. It's there. So what I want to do is go all the way down, if it will let me. And then go all the way across. And that's the table value. Negative 0.0, and this is the 8. Looks like it's 0.4681. And that's what it is. 0.4681. So that's how you use the table value. Or use a table to find table values for given z-scores. Now we got these 3 examples. Now there's more information involved. So here's what we're going to do. I'm going to draw a picture of each one of these. Now 0's in the middle. The z-score of 0's in the middle. 1.48 would be over here somewhere. So what we're going to do is we're going to find the table value. I'm going to call that TV. TV. So for 1.48, I'm going to move here. Look at this one because that's a positive. I'm going to erase all those. Want all that gone. If it'll let me. We're going to look at it as if there's nothing on this table. Just a plain old view. So looking for 1.48. So there's the 1.4, and then there's the 8. 1.4, and then there's the 8. Got that? 0.9306. So the table value is 0.9306. What do we say about the table? Well, since we're doing less than, if we were to shade that, we would shade all that. And the table value represents what? Table value represents the area to the left of the Z. So what that means is, in this case, the area is the table value, 0.9306, because less than is left. Now let's look at this one. Z greater than 3.14. I'm going to draw the curve. 3.14 would be way over here somewhere, where Z equals. Now greater than would be that somewhere, would be that region to the right, because greater than is to the right. Greater than points to the right, so we'll shade that over there. So what we want to do is find the table value first for 3.14. So 3.14, let me erase this if I can. It's just not going to let me do what I want it to do. So once again, we're looking for 3.14. So there's 3.1. And here's the 4. And they're converging at 0.992. So the 0.99, what I say it was? 9992. But keep in mind that this 0.9992 is the area to the left. So it represents all this area. That's what it represents. So how do we find this area then? That's the question. Well, if the whole thing is 1, and this much is 0.992, to find this, we have to find 1 minus 0.9992, which means the answer is 0.0008. And let's use a calculator just to make sure, because sometimes we can mess up our decimals really easily. 1 minus 0.9992. And anytime you see that, that means that, well, it's a good thing I did this. It means that you have an 8 with the decimal in the end. You move, since it's a -4, it's scientific notation, so you move it 1, 2, 3, 4 to the left. So it actually is this. That's what that e to the -4 means. It's scientific notation. So the area is 0.0008. Now this last example is a betweener. So we have z equals 0 in the middle. So you have over here we have negative 1.09, and over here we have 0.88. So what that means is we want the area in the middle. Area in the middle. So we still follow the same process. So I'm going to erase some of this. Give me some space. What we're going to do is we're going to find the table value for each. So let's do negative 1.09. I may do this kind of quickly, by the way. So we got negative 1.0, and then 9 is way over here. See that 9? So we get 0.1379. 0.1379 is this table value. No, it's not. Is it? Yeah. I want to make sure we're looking at the negative. Yeah, negative 1.09. 0.1379. Yep, that's good. And then 0.88. Its table value is there's the 0.8, and there's the 8.88, and then there's the other 8 up there. It is 0.8106. 0.8106. Make sure. Yep. Now here's how you find the area in between. This 0.8106 represents from there all the way to the left. This 0.1379 represents from there all the way to the left. So what that means is we need to get rid of this to end up with what's in the middle, just from there to there. To do that, you subtract the bigger minus the smaller, or the right minus the left. So we're going to do 0.8106 minus 0.1379. We're going to take out our calculator to do that. 0.8106 minus 0.1379. We do get 0.6727. So that's the area between those two. So the moral of the story is, if it's less than, you just use the table value. If it's greater than, you use 1 minus the table value. And if it's the in-betweener, you subtract. I think probably right minus left would be better. But it's table value of B minus table value of A, or big minus small. But it's always subtracting table values. So let's say that again. Less than is the table value, greater than is 1 minus the table value, and if it's the in-betweener, it's the bigger minus the smaller. So here we're going to put it all together to answer real questions now. First question is, here we go, we got the scores x represents the data values, are normally distributed with the mean as 75 and a standard deviation of 10. What is the percent of scores below 70? So basically what we're finding is, we have to use x is less than 70, and we need to convert that to a z-squared. To do that, we use that formula. I'm going to write it up here. It's the data value minus the mean divided by standard deviation. So we're going to take that x value, which is 70, and it's the less than, but we don't use that for the z-squared. So we have 70 minus the mean is 75, and divided by 10. So 70 divided by 75 is negative 5 over 10, which is negative 0.5. Got that? So we need a table value for negative 0.5. Or it's actually negative 0.050. Negative 0.50. And if you want to, it doesn't ever hurt to use the calculator just to make sure. 70 minus 75 divided by 10. We get negative 0.5, which is the same as negative 0.50. Negative 0.50. So negative, and you go to the negative table. Let's first notice that this is the 0. First column is the 0, 0 column. So you got negative 0.5, and then this is the 0. So negative 0.5, and then the 0 is this column. So it's 0.3085. 0.3085. .3085. Check it to make sure. Yep. And so the question is, what percent? Well, since below is the same as less than, and table values are the same as less than, table values are the same as less than, we use the table value and convert that to percent by moving it 2 places to the right. So it's 30.85%. So once again, use the formula, convert the data value to a z-score, find the table value, and then you think, do I use that table value, or do I do something else with it? Since it's less than, because below is less than, we use that table value, convert it to percent. Now this next question is scores above 85, so that's x is greater than 85. So the same process. Z equals 85 minus the mean, which is 75, divided by standard deviation, which is 10. 85 minus 75 is 10. 10 divided by 10 is 1, same as 1.00. Go to the table. We want 1.00. So there's 1.0, and then 0, the second 0 is up there, so they converge at 0.8413. 0.8413. Why it does that, I'll never know. 0.8413. Now, do we use that table value? No, we do not, because it's a greater than. Anytime it's a greater than, we do 1 minus the table value. So 1 minus 0.8413, 1 minus 0.8413, I'm just going to move that over out of my way, is 0.1587. Since it's asking for a percent, the percent is 15.87% of the scores are above 85. And then the last example is a betweener. So once again, we do the z-scores for each in this case. So 65 minus 75 divided by 10, and then for the 85 it would be 85 minus 75 divided by 10. That one's easier. It's 1. We already have the table value for that one because we've already done it up here. We found it to be 0.8413. Now this one is negative 10 over 10, which is negative 1.00. I can't read that. Negative 1.00. So we've already done this for part B. So I need to find the table value for negative 1.00. Go back to the negatives. Negative 1.0, and then there's the second 0, so they converge at 0.1587. 0.1587. I forget what it was. 0.1587. So, since it's the in-betweener, what are we going to do? We subtract bigger minus the smaller. So we just call it area. And when we subtract that, 0.8413 minus 0.1587, we get 0.6826, which means the percent is 68.26%. Sorry about all the movements that it was happening. I think it's because this table is in a picture file in Word, but that's how you do it. The main thing to do is use this formula to convert data values to z-scores, and then recognize that table values are areas to the left. So if it's less than, use the table value. If it's greater than, it's 1 minus the table value. If it's in betweener, do the bigger minus the smaller. And we're done.